All right, this is 9-3 notes. Day 1, part 1. Some background information. One is proportions. A over B equals C over D. Means A times C is equal to, A times D is equal to B times C. It's what's commonly known as the butterfly method to solve. Okay? The second information is similar triangles. These are triangles that have congruent angles and proportional side lengths. For example, two triangles. This is big, small. This is A, this is B, and this is C. This is D, and this is E, and this is F. This length is 3, this length is 4, and this length is 5. This length is 6, this length is 8, this length is 10. Oh, that was silly. I'm silly. So I'm going to do 6, 8, 10 over here and 3, 4, 5 over there. So this is 6, and this is 8, and this is 10. And this is 3, this is 4, and this is 5. Okay. So the angles are congruent. Right? Angle A is congruent to angle D. Angle B is congruent to angle E. And angle C is congruent to angle F. And 6 over 3, you can see that, 6 over 3 is equal to 10 over 5. You can see that. Notice I followed the same path, 10 to 5, 6 to 3. Now, you can also do 8 to 4. All right, so 6 to 3. 10 to 5, and 8 to 4. As long as you, as you follow the path. Now, you can see here that 3 times 10 equals 6 times 5, and 5 times 8 equals 10 times 4. Okay? And you can see that 3 times 8 equals 6 times 4, and I think that's about it. Okay? So that's what is meant by proportional sides. Similar triangles may not be the same size, right? But they have congruent angles and proportional sides. Okay, so that's the background information for 9.3. And 9.3 is altitude to hypotenuse problems. Oh, dang it. Dang it. There's also background information of something called the geometric mean. Okay, now the geometric mean is this. I'm going to call this GM, for geometric mean. The GM, okay, and I'm going to, the GM of two numbers okay, is the square root of their product. So, if x equals the square root of a times b, then x is the geometric mean of a and b. The geometric mean of two numbers is the square root of their product. So, if x equals the square root of a times b, then x is the geometric mean of a and b. Okay? Also, this makes a proportion. And the proportion is x over a equals b over x. This means, this is saying that x is the geometric mean of a and b, shown like this. X over a equals b over x. X is the geometric mean of a and b, which means x times x equals a times b, or x squared equals A times B, or I can say that x equals the square root of A times B. Just like I said, x is the geometric mean of A and B, means that this is saying that x over A equals B over x. And if I apply the proportion rule or the cross product, then x over A is equal to x times B, means x times x equals A times B, or x squared equals A times B, or x equals A times the square root of A times B. Okay, so the geometric mean. All right, so the background for 9.3 needs to be three things. One is proportions. Two is similar triangles that have congruent angles and proportional side lengths. Those are triangles. Okay, so here's two triangles. They're the same angles and they have congruent sides, or not congruent sides, proportional sides. So triangle ABC, similar, now that's the symbol for similar, is similar to triangle. Now let's follow the same path here. A times A to B to C means D to E to F. Okay? All right. So, the last piece is the geometric mean. Now, I'm going to show you that tomorrow, but the geometric mean of two numbers is the square root of their product. This also makes a proportion. X over A equals B over X. So when we solve this proportion, we get x times x equals A times B, or x squared equals A times B, or x equals the square root of A times B. Okay? Now this will apply to three problems. Okay, and these are altitude to hypotenuse problems. Okay, and the diagram is this. We have a big right triangle. And then we have the altitude to the hypotenuse. And this is a leg, and this is a leg. And what we have now are three right triangles. Here's one, smaller one. Here's two. And we have the bigger one. The leg, and the hypotenuse. So that's the background information for 9.3, and we're going to get rolling on some of these problems, okay? I will talk more about this, but this is a good video to watch.